Good morning, dear students. So in today's class, we will see equations with variable coefficients. So till now we were seeing equations involving constant coefficients. Now we will move on to equations with variable coefficients, and we are going to consider equation of the form RR plus SS plus TT plus f of xyz PQ equal to 0, and here R, S and T, they are continuous functions of x and y which has continuous partial derivatives. So we are going to look at what is the solution or how to classify this type of equation, and hence how to find the solution of such type of equation. So we are looking at this peculiar type of equation, so which is in the form RR plus SS plus TT plus f of xyz PQ equal to 0. So R, S and T, they will be functions of x and y. So that is the type of equation. Now when you have a second order PD of this form, so it can be basically classified into three types. The three types are, first is the equation can be either hyperbolic, then equation can be parabolic, or equation can be elliptic. Now the equation is said to be hyperbolic at a point xy in the domain D if when we find s square minus 4rt, so s square minus 4rt, it is greater than 0, we say that equation 1 is hyperbolic. Now it is parabolic if for all xy in the domain D, s square minus 4rt is equal to 0, and again the equation is said to be elliptic if for any point xy in the domain s square minus 4rt is less than 0. So these are the different classification of the equation of type 1. So when you take an equation of type 1, so it can be put into any of these three categories, either hyperbolic, parabolic or elliptic. So this is how we do the classification. So we will see a few examples for each of this. Okay, so the first one is, so the problem is to classify the PD. So the first question is, you have dou square z by dou x square, okay, minus dou square z by dou y square equal to 0. So you have, this is small r minus t. R minus t is your equation. So capital R is 1 and capital T is minus 1. Therefore s square minus 4rt is equal to, so you will get minus 4. So minus 4 into minus 1. So the value is 4. So it is greater than 0 for all xy in the domain of your equation. So therefore the equation is hyperbolic. And next example is dou square z by dou x square equal to dou z by dou y. So here you have r equal to 1 and s and t 0 ആണ്. So you don't have any other second order derivatives. So s square minus 4rt, that is equal to 0. So 0 ആകുമ്പോൾ the equation is going to be parabolic. And the third one is dou square z by dou x square plus dou square z by dou y square equal to 0. So r and t is 1. S square minus 4rt will be minus 4. So the equation is elliptic. And the next one is your xyr minus x square minus y square into s minus xyt plus py minus qx equal to 2 x square minus y square. So you have capital R, capital S and capital T. So s square minus 4rt. So you will get as x square minus y square whole square plus 4x square y square. So which is equal to x square plus y square the whole square. So it is greater than 0. So positive ആണ്, അപ്പോൾ hyperbolic ആവും. And so okay, those are the examples. So next we will see what is called a canonical form. Now when you have an equation of this type, so if you have an equation of the form RR plus SS plus TT plus f of xyz PQ equal to 0, By using suitable substitutions, u equal to u of xy and v equal to v of xy, our equation can be made into simpler form so that we can calculate the solution easily by the methods you have learned previously. നമ്മൾ ഇതുവരെ പഠിച്ച മെത്തേഡ്സ് വെച്ച് നമുക്ക് സോൾവ് ചെയ്യാൻ പറ്റും. അപ്പം ആ ഇക്വേഷൻ നേരെ അങ്ങനെ തന്നു കഴിഞ്ഞാൽ നമുക്ക് സോൾവ് ചെയ്യാൻ ഡിഫിക്കൽട്ട് ആയിരിക്കും. ബട്ട് യൂസ് suitable substitution we can solve for this. So we can reduce the equation to a much simpler form. So they are called the canonical forms of the equation of type type we are seeing now. So the canonical forms are easily integrable. ഇനി ഓരോ ഇക്വേഷനും ഹൈപ്പർബോളിക്കോ എലിപ്റ്റിക്കോ പരാബോളിക്കോ ആവുന്നതിനനുസരിച്ച് the substitution changes. So we will look at what happens in each case. So when you have equation of this type, so this is our equation. So I am putting u equal to u of xy and v equal to v of xy. From u name v name. So by chain rule of differentiation, so if u equal to u of xy and v equal to v of xy, so x and y, they can be expressed as functions of u and v. അപ്പോൾ നമുക്ക് ഈ partial derivatives, you have the partial derivatives p, q, r, s and t. So they can be expressed in terms of u and v. അപ്പം നമ്മൾ p എഴുതുമ്പോൾ p is dou z by dou x. So by chain rule, you can put it as dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. അതുപോലെ q is this dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. And similarly, p and q, it is again, when you take the derivatives with respect to x and y for p and q, that will give us r, s and t. For r, s and t, by the same technique, you can express as derivatives in terms of u and v. So we are not doing that. So we'll do all those things in problems. Okay. This is to give an idea of how do we get that. Okay. And once you find p, q, r, s and t in terms of u and v, so on substituting these values in your equation, so we will get the equation in the form a dou square z by dou u square plus 2b dou square z by dou u dou v plus c dou square z by dou v square plus f of u v z dou z by dou u dou z by dou v equal to 0. So on substitution, this is what you are going to get. ഇനി അവിടെ എ ബി സി എന്ന് പറയുന്നത് that will be these values. Okay. അപ്പോൾ നമ്മൾ സെക്കൻഡ് ഡെറിവേറ്റീവ്സ് ഒക്കെ എടുത്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിയുമ്പോൾ നമുക്ക് ഇതാണ് കിട്ടാൻ പോകുന്നത്. So we just need this values a, b and c. So a is r dou u by dou x whole square plus s dou u by dou x into dou u by dou y plus t dou u by dou y whole square, and b is r dou u by dou x into dou v by dou x plus 1 by 2 s times dou u by dou x into dou v by dou y plus dou u by dou y into dou v by dou x, then t dou u by dou y into dou v by dou y, and r and c is r dou v by dou x whole square, then s dou v by dou x dou v by dou y plus t dou v by dou y whole square. So the first two, they are of the similar type. Okay. A and C. Okay. And the function capital F of u v z dou z u by dou z by dou u dou z by dou v. So that is obtained by transforming the function f of x y z p q. And now we will look at what is the value of u and v. So therefore this equation we have obtained here. So number substitution u v കൊടുത്തു കഴിഞ്ഞപ്പോൾ നമുക്ക് കിട്ടിയ equation. So this equation is known as the canonical form. ഇനി നമ്മൾ actually ഈ ABC evaluate ചെയ്യുമ്പോൾ sum of them becomes 0. So this is actually a simpler form when you actually evaluate it with suitable u and v. So we'll figure out how to find u and v. Now for finding u and v, so we will use a quadratic equation r lambda square plus s lambda plus t equal to 0. Now for this quadratic equation, so the discriminant is s square minus 4rt. The discriminant can be equal to 0, positive and negative. So അപ്പം ഓരോന്ന് വരുന്ന കേസിലും നമ്മുടെ ഇക്വേഷൻ 3 കാറ്റഗറി ആയിരിക്കും. ഓക്കെ, because r, s and t that is in your first general equation. So അതിനനുസരിച്ച് s square minus 4rt യുടെ വാല്യൂ അനുസരിച്ച് the equation can be elliptic, parabolic or hyperbolic. So using the discriminant value, so we will look at how to find the values of u and v. Now the first case is when s square minus 4rt is greater than 0. S square minus 4rt positive ആവുമ്പോൾ you will get r lambda square plus s lambda plus t equal to 0. Now positive ആവുമ്പോൾ there will be two distinct real roots. Okay, so two distinct roots varum. The roots are going to be equal to, so let it be lambda 1 and lambda 2. Now using lambda 1 and lambda 2, so you write down these equations. So nammal idine characteristic equations ennaanu vilikka. So that will give the equations dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. Now solve this equation for the solution. So from the first equation, solving the first equation, you will get f1 of xy equal to c1, and രണ്ടാമത്തെ equation solve ചെയ്യുമ്പോൾ you will get the solution f2 of xy equal to c2. Now the choice of u and v for this type of equation is u equal to f1 and v equal to f2. So for finding now p, q, r, s and t, we will be using this substitution of s square minus 4rt greater than 0 ആകുമ്പോൾ corresponding distinct roots കണ്ടുപിടിക്കുക and solve for the equation dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. So that will give you two solutions. Our solutions ആയിരിക്കും u v. And when you substitute the equation, നമ്മൾ ആ എ ബി സി വാല്യൂ കണ്ടുപിടിച്ച് കഴിയുമ്പോൾ this is how you are actually getting the final form. So the final form of the canonical form is dou square z by dou u dou v equal to phi of u v z dou z by dou u dou z by dou v. അപ്പം we will see this in problems. നമ്മൾ പ്രോബ്ലം ചെയ്യുമ്പോൾ സിംപ്ലർ ആണ്, നിങ്ങൾക്ക് ഒന്നുകൂടെ മനസ്സിലാവും. ഓക്കെ, and the second case is when discriminant is equal to 0. So discriminant equal to 0 ആകുമ്പോൾ there will be equal roots. So you will have two roots. So both are equal. രണ്ടും lambda 1 ആയിരിക്കും. So you will have only a single characteristic equation. Okay. So you will get the characteristic equation dy by dx plus lambda 1 equal to 0. So the solution will be f1 of xy equal to c1. Now u in the choice f1 ആയിരിക്കും and v will be chosen as f2, where f2 is any function such that f1 and f2 are linearly independent. So f2 എന്ന് പറയുന്ന linearly independent ആയിട്ടുള്ള function choose ചെയ്യുക. So that is the choice of u and v. And in the second case, for parabolic case, final canonical form will be dou square z by dou u square equal to phi of u v z, അല്ലെങ്കിൽ dou square z by dou v square equal to function phi. So those are the